this lecture, we are going to understand the basic concept of FMEA and its elements, risk priority number, and evaluate FMEA results from process, products, and services. So, what is failure mode effect analysis or FMEA? It is a tool used for the prevention of the problem, and this tool helps us to identify and anticipate potential failures, identify potential causes of the failures, prioritize the actions required to treat those failures, and taking actions to reduce, mitigate, or eliminate failures. There are basically two types of failure mode effect analysis or FMEA. These are the process FMEA or PFMEA, which focuses basically on process or identify those causes of failures in process and try to reduce them, and design FMEA or DFMEA, which focuses on product or its components. This is an example of the process FMEA. The main differences between the process FMEA and the design FMEA is in the first column. In design FMEA, the first column is generally used to show the product or component part. The columns or components in FMEA diagram are easy to understand. I will explain the basic important components of FMEA here. We'll talk about the severity, occurrence, and detection, and also the risk priority number or RPN. First, let's start with the severity. What is severity? Severity is used to quantify the severity of the impact of the failure mode. The scale for severity ranges from no effect on the low end to safety hazard, which may include the loss of life also without any warning. The severity guidelines as given by Automotive Industry Action Group AIAG 4th edition is given on the screen. Here we can see that we assign higher score when the severity due to failure is very high. For example, we have given severity score of 10 if there is a chance of injuring a customer or employee. Similarly, score of 1 suggests there is no effect and it can be unnoticed and there is no effect on the performance. So based on the severity of failure, we can assign the severity numbers. I'll also provide you this table in the PDF format in the resources section so that you do not have to memorize all these points. Next, let's look what is occurrence. So what is occurrence? Occurrence is used to quantify the frequency of occurrence of the failure mode. The scale of occurrence ranges from very unlikely on the low end to very likely on the high end. There are many different kinds of failure causes which should be identified properly and documented. The causes which occurs or repeats more is more dangerous and needs to be handled first than a failure cause with low chances of occurrence. On a scale of 1 to 10, the higher score indicates high occurrence, which should be given more focus to solve than a lower score value. The occurrence guideline as given by Automotive Industry Action Group AIAG 4th edition is given on the table. Here we see that if there is higher number of occurrence, that means if the occurrence of failure is more than once per day and more than 1 in 10 or more than 100 per 1000 occurrences, then we give it a score of 10, or simply said, we give higher weight for those failure events which are occurring very fast and frequently, and we give low occurrence score to those failure events which are not happening frequently. As I told earlier, you do not have to memorize this table, as I will be providing you all this information in a PDF format, and you can download that from the Resources tab. Let's now study about another term, detection. So what is detection? This component is used to quantify the ability to detect the failure at a specific process step or at a product or a component part level. The scale for detection ranges from almost certain on the low end to not possible on the higher end. Detection indicates how easy or hard the quality assurance or quality inspectors can detect the causes of the failures. On a scale of 1 to 10, 10 indicates a situation very difficult to detect, whereas subsequent lower value indicates higher chances of detection. The detection guideline as given by Automotive Industry Action Group, AIAG, 4th edition, is given on the table. Here we see that if the defect is very difficult to detect, then we give it a higher score. And if the defect is obvious and they can be detected to prevent customers from getting affected, then we give it a lower score. So let's study another term, risk priority number. Risk priority number denotes the multiplicative effect, that is RPN equals the multiplication of severity value, occurrence value, and detection value or values assigned to each of the previous 3 columns. Although generally, while picking up anything for improvement, which is that failure mode having the highest risk priority number, there may also be additional prioritization criteria, such as where detection value or severity value is at the highest level. We try to prioritize improving that failure mode first. The FMEA is an important topic in many aspects of project management and improvement, such as Kaizen, Lean, Six Sigma, basically in the measure, analyze, improve, and control phase 2. So please give emphasis on the risk priority number here. Thank you so much for listening to me so far.